Today we will solve the problem 2.21 of Griffith third edition Introduction to Quantum Mechanics. Uh, I have already uploaded one lecture on the same problem, but which is very lengthy and complicated. Here I have used very simple mathematics and I have solved this in a very simple manner. I have separated this lecture into two parts. It contains four subdivisions. I have separated A and B in this lecture and C and D in part 2. Here the problem 2.21 is the Gaussian wave packet. A particle has the initial wave function psi of x and 0 is equal to a e power minus a x squared, where a and small a are the real and positive constants. First tuition is you normalize psi of x and 0. In order to normalize, you have to integrate between minus infinite to plus infinite. Modulus psi squared dx is must be equal to 1. Here, modulus psi squared is you square the a normalization constant a squared. If you square the exponential term, you will get e power minus a x squared dx, which must be 1. So this is the Gaussian integral with alpha equal to 2a. Alpha equal to 2a. The result of this integration is square root of pi by alpha. So this will become a square. This integral value is square root of pi by alpha. Here alpha is 2a. So square root of pi by 2a, which is equal to 1. That means a is equal to 2a over pi whole power 1 over 4. Now we will move on to the next section. Next question is find the psi of x and t. To find the psi as a function of t, we need the phi of k, that is on k basis, from position basis to momentum basis. In fact, k basis, which is equal to pi of k is equal to phi definition 1 over square root of 2 pi integral between minus infinite to plus infinite psi of x and 0 e power minus ikx dx. This is the Fourier transform of position basis. So here you replace psi of x and 0, which I have mentioned. This that is normalization constant and wave function is exponential e power minus ax squared. Just now we have seen multiplied by e power minus ikx dx. Now you keep the term outside the integral as it is. Then this inside the integral, you combine both the integral exponential term. Then you can write e power minus this ax squared. Here you can use plus ikx because you have taken minus outside. So pi of k is equal to this one. Now we will find the psi of x and t. Now we got this expression. This is the standard Gaussian integral for which the result is that is the integral between minus infinite to plus infinite e power minus ax squared plus bx dx is equal to square root of pi over a e p squared over 4a. Here p squared is a coefficient of x. P is coefficient of x and a is coefficient of x squared. This is the standard thing, coefficient of x squared. So here coefficient of x is equal to ik. Maybe I will use different color, ik. Sorry, ik. It is ik. coefficient of x is equal to ik, and coefficient of x squared is a in our case. Simply I will explain the argument minus k squared over 4a. You add and subtract it in the argument of this exponential term, you will get perfect square, and you can simplify, integrate using Gaussian method, and simplify it. You will get, it's a very standard result, square root of pi by a, e power minus k squared 4a. That is p. I have told that coefficient of x, which is ik. If you square it, you will get I squared k, which is minus 1 k squared over 4a. Here coefficient of x squared is a. Now you can remove the sum of this thing in the constant. You can cancel this pi and this pi. Remaining thing is you will get 1 over square root 2 first term, then 2a over pi, then this 1 over, because pi can cancel the square root of a. This is 1 over 4. Now you bring this square root 2 here, then that will become, this will become 4. This will become 4. This will become 4 when you bring it just inside. Similarly, if you bring this 1 over square root of a, then you will get sorry, you will get a squared here. That is a square, because that is square root of a. When it comes inside the 1 over 4, this will become a squared. Now you can cancel this a and this a squared. You will get a, simply a. Similarly, if you cancel 2 and 4, 2 you can cancel, and this 4 will become 2. This 4 will become 2. So this can be written as simplified as 1 over square 2 pi a, my whole power 1 over 4, and this exponential term minus k square over 4a. Now we got phi of k is equal to 1 over 2 pi a whole power 1 over 4 e power minus k squared over 4a. Now, in order to find the wave function which depends on position and time, psi of x and t is equal to, by definition, 1 over square root of 2 pi phi of k. As I said, this is the different amplitude, and this is actually the superposition. This is called the inverse Fourier transformation. E power minus e power I kx minus omega t. You are integrating with respect to k. Then what is omega? You know, H cross omega is energy in quantum mechanics is equal to p squared over 2m. P squared is h cross k. P is h cross k. P squared is h cross squared k squared over 2m. Then what is omega? Then omega is equal to, you cancel this h cross and here h cross squared. So omega is equal to h cross k squared over 2m. So I have replaced this as h cross k squared over 2m. Of course, we have t here. Then for convenience, I'm writing this as I'm keeping the psi of k we have seen this yellow color 1 over 2 pi a 1 over 4 and e power minus k square over 4a. This is psi of k. I have replaced the psi of k, and the remaining thing is this one. Now I can rewrite it for mathematical convenience. This I can write exponential. You take minus k squared out, where in two places you have k squared. So first one is 1 over 4. Here you have 1 over 4. Here h cross k squared t over 2m. So k squared I have taken out already, minus k squared I have taken out. So here you have I ht over 2m plus ikx, this one, this x coefficient plus ikx. Now we have to find this integral. So now we got this expression. Here you can see this is a standard Gaussian integral, that is integral between minus infinite to plus infinite e power minus ax squared plus bx tx is equal to square root of pi over a e power p squared over 4a. So here we are integrating with respect to x. Here we are integrating with respect to k. So k and x interchanged. So this is a k squared p k. What is coefficient of k squared? This one is coefficient of k squared. Coefficient of k squared. Then what is coefficient of k, that is ix? Coefficient of k is equal to ix. So now you apply this formula. So you will get square root of pi over this coefficient of k squared. This is a is coefficient of k squared, which is equal to 1 over 4a plus I h cross t over 2m. Then what I'm going to do it here is I'm multiplying and dividing by 4a. I'll come to it later. Then minus uh, x squared over here the coefficient of x is equal to p is coefficient of x, which is equal to ix. That is minus x squared over 4a. 4a, a is coefficient of k squared, 1 over 4a plus I h cross t over 2m. Here I am multiplying and dividing by a for mathematical simplification. So if I bring 4a here inside, this 4a will get cancelled. This will become 1 plus if you bring 4a here, this 4 will get cancelled with this 2, which will become 2. So 2 h here you have a h a t over m. Similarly here, if you take 4a multiply by 4a, if you bring this 4a inside, you will get 1 plus I to h cross a t over m. Here you have square root of 4a pi. Now we will simplify this one. Here you can simplify sum of the term. 1 over square root 2 pi get cancelled with this square root 2 pi. Pi and pi will get cancelled. This square root 2 will get cancelled with the square root 4, which will become 2. Now in the numerator, you got here you got 1 over 2 pi a power 1 over 4. Then this here in the numerator you have 2a. If you bring this 2a, you will get to 4. Uh, this 1 will get cancelled. 1 I am replacing this by because this is square root. This is 1 over 4. So you have to square this. So 4, here you have a square. So now you can cancel this a squared with this a, and you can cancel this 2 and 4, which will become 2. So this is 2a over pi power 1 over 4, and this denominator I am keeping it as it is. So 1 over square root of 1 plus I 2 hat over m. Similar exponential minus ax squared over 1 plus I 2 h cross at over m. This is the time dependent wave function. We will see the part C and D in the next lecture. Thank you very much for watching my video and supporting me continuously.